Hi guys, this is another video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you are looking for elsewhere. There's a lot of information out there. Be aware that I am not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today, we're going to be going over metric conversion and simplifying fractions. I'm not going to go in depth on metric conversion. I'm simply going to go over the quickest and most efficient way to convert between meters, liters, and grams all the way up to kilometers, down to millimeters, up to kiloliters, down to milliliters, up to kilograms, and down to milligrams. Now, a great way to remember this scale is by creating different acronyms. A common one is King Henry died unusually drinking chocolate milk. There are many other sayings out there. This is just a common one. So K on King stands for kilo. Kilo means that you have 1,000 of something. So for example, if you're measuring distance or meters, a kilometer means you have 1,000 meters, 1,000 of them. H for hecto, that stands for 100 of something. Deca is 10 times. Your standard unit of measurement, meter, liter, or gram, we just have one of something. If we are looking at D for deci, we are referring to 1/10 the size of something. C for centich, 1/100th, and M for milli would be 1/1000th. So for example, if I had a millimeter, it would take 1,000 of those to make up 1 meter. So milli means you have 1,000th of your standard measurement. So very small, very large. All right, that's as in-depth as we're going to get. We're going to focus on converting between the different units of measurement, kind of like converting between feet and inches. If I said 1 foot is how many inches, we would say 1 foot equals 12 inches. It's the same thing, but it looks different and has a different label. However, with metric conversions, they're much easier and faster. And that's what we're going to focus on. So the three measurements that we're dealing with are meters, liters, and grams. Meters measure distance. Liters measure liquids or volume. And grams measure mass. Not weight, mass. That's how much matter is inside an object. All right, we have 6 examples that we're going to go through, and we're going to keep this chart in mind. Now, you're not always going to have a nice chart with you, so that's where this acronym comes in handy. King Henry died unusually drinking chocolate milk. So we can remember that kilo is the largest, all the way down to milli, which is the smallest. So our first example is we want to change 4 kilometers to millimeters. So I want to know how many millimeters it takes to make up 4 kilometers. So our first step, write down what we're given. We're given 4 kilometers. Second, locate your decimal. Our decimal on whole numbers is right up the backside of that number. Next, we're going to determine what we're converting it to and remembering where we are starting. So we are starting with 4 kilometers. So I'm going to find kilometers. It is the largest on this chart. We are converting it to millimeters. What are we going to do? We're going to look at the direction on the chart that we would go and count how many place values we would have to move to get there. So to go from kilometers to millimeters on this chart, I would have to move once, twice, 3 times, 4 times, 5 times, 6 times on the chart to the right to get to millimeters. So that means I'm going to move my decimal the same. So 1, 2, 3, 4, 5, 6 to the right. So move your decimal 1, 2, 3, 4, 5, 6 place values to the right. Anytime you have empty spaces, fill them with zeros. Zeros are like friends. They fill in the void. All right, so our decimal moved from there all the way back here. What does this mean? This means that it takes 4 million millimeters to make up 4 kilometers. Our next example, 50 liters. We're going to convert to kiloliters. So first step, again, write down your number. Second step, locate your decimal. The decimal on this whole number is going to be right behind it. All right, next, we locate where are we starting and what are we converting it to. We are starting with 50 liters. Liters is our basic unit of measurement, and we're going to convert it to kiloliters, which is in the left direction. So once, twice, 3 times left. So we're going to mirror that and move our decimal once, twice, 3 times left. So once, twice, 3 times left. I have 1 space to fill in with a 0. It is no longer there anymore. So what does this mean? 50 liters is the same thing as having 5 hundredths of a kiloliter. Can you write that 0? Absolutely. Why do we not need to write that 0? It's not sandwiched. It's not a significant 0. It's not necessary. So again, 5 hundredths of a kiloliter is the same thing as having 50 liters. Our third example, 47 hundredths of a kilogram. We want to know how many grams does that make up? So first step, write down your number. Next, locate your decimal. It's already there in the front. Next, we're going to determine what are we starting with and what are we converting it to. We are converting from kilograms to grams. So again, kilograms, kilo is in the far left. We are changing it to gram, which is our basic unit of measurement. So that would be once, twice, 3 times to the right. So we're going to move our decimal 3 times to the right. Once, twice, 3 times to the right. Fill in spaces with zeros. So that means 47 hundredths of a kilogram is the same thing as having 470 grams of something. Same exact thing. Again, we're not going in depth on the meaning of this. I'm just going quickly and efficiently through how to do these conversions. All right, our fourth example, 3.4 centimeters. I want to know how many millimeters are in that. So first step, we write down our number. Next step, we locate our decimal. It's right between the 3 and the 4. Next, we're going to determine what are we converting it from and to. We're converting from centimeters to millimeters. Centimeters is right here, and millimeters is 1 to the right. So centimeters to millimeters. So because we move 1 to the right, we're going to move our decimal once to the right. So now it's behind the 4. That means it takes 34 millimeters to make up 3.4 centimeters. One thing that I have not mentioned, our abbreviation for meter is M, our abbreviation for liter is L, and our abbreviation for grams is G. So whenever you're looking at your M's, remember that MM stands for millimeter. When you have 1 M, that stands for 1 meter. All right, let's move on. 0.5 milliliters, we're going to convert it to liters. So first step, write your number. Next step, locate your decimal. It's already there. Now we're going to determine what are we converting it from and to. We want to convert from milliliters. So milli is the smallest. So milliliters right there. I'm converting it to liters. That's our basic unit of measurement. So that would be once, twice, 3 times in the left direction. So we're going to move our decimal 3 times in the left direction. Once, twice, 3 times. We have 1, 2, 3 empty spaces to fill with zeros. So that means half a milliliter is the same thing as having 5 10,000ths of a liter. Let's see, 10, hundreds, thousands, 10,000ths. Yep. Our last example for metric conversions, 3.7 liters. We want to know how many milliliters will fit in 3.7 liters. Now, 3.7 liters, that's almost a recognizable number. That's like having a 2-liter bottle of Pepsi. So a little bit more. So basically, I want to know how many milliliters make up slightly more than, a 2-liter bottle of Coke. First up, write down your number, 3.7. We're going to convert, second, make sure you know where your decimal is. It's right in the middle. We found it. All right, next. Determine what are you converting from and to. We're converting from liters to milliliters. Liters is our basic unit of measurement. It's going to be found in the middle. Milli is the smallest, so milliliter is all the way on the right on our chart. So that means we're going to move in the right direction. 1, 2, 3 times to the right. So move your decimal 3 times to the right. Fill in any empty spaces with zeros. So that means 3.7 liters is the same thing as 3,700 milliliters. All right, I hope this has helped with converting metrics from different sizes. Again, use this acronym to help you, and there are other acronyms out there that will help. This is just a common one. So remember K if you are going from kilo to milli. K is the largest, down to milli or M, which is the smallest. And whenever you're converting, always determine what you are starting with and what you're going to. You'll either move left or right. Count how many times left or right you move. And that's the same thing that you do with your decimal. All right, the second thing we're going to be covering is simplifying fractions. So there are 3 basic rules that we need to know to determine if a fraction is in simplest form. So if one of these 3 rules apply, you have a simplified fraction. So our first rule is we know a fraction is simplified when the numerator and the denominator have no common factors besides 1. So I'm just going to briefly look down at this example here, 20 over 48. 20 and 48 have lots of common factors. For example, 2 will divide evenly into both. 4 will divide evenly into both. So those are just 2 examples of common factors besides 1. That means 20 over 48 is not in simplest form. That means it would be inappropriate to leave your fraction as such. Second, a fraction is simplified when the denominator is prime. Now, if I were to look at this example, I would see that our denominator, the bottom number, is not prime, that means that this fraction potentially, most likely, is not simplified. Our third rule that we need to be aware of is a fraction is simplified when the numerator is prime and will not divide evenly into the denominator. All right, so we're going to do a couple examples of simplifying fractions and seeing if we can apply maybe one of these rules to see if we are finished. So our first example is 20 over 48. We will first look at the first rule. Do they have any common factors besides 1? If they do, our fraction is not simplified. So, do 20 and 48 have any common factors? Yes. Like I said earlier, 2 will go into both, 4 goes into both, possibly other numbers. I would have to use a t-chart to determine all of those factors. So, what do we want to do to simplify it the fastest? You always want to divide by the GCF, the greatest common factor. So, we want to know what's the largest number that will fit evenly into 20 and 48. Well, that happens to be 4. 4 is the GCF, or the greatest common factor, of 20 and 48. So it would be the most appropriate number to divide both numerator and denominator by. So I would do that. 20 divided by 4, we get 5. 48 divided by 4, we get 12. Now I'm going to look at some of my rules to determine if we are finished. So the first rule says, our fraction is simplified when the numerator and denominator have no common factors besides 1. Do 5 and 12 have any common factors besides 1? Well, the factors of 5 are 1 and 5. Does 5 go into 12? No. So that means this is simplified. We know we are finished. Do any of the other rules apply by chance? Let's see. A fraction is simplified when the denominator is prime. Is our denominator 12 prime? No, it's not. It's divisible by other things. So rule 2 is useless for us right now. So let's look at rule 3. A fraction is simplified when the numerator is prime. Oh, 5 is prime. It's only divisible by 1 and 5. And it will not divide evenly into the denominator. So will 5 divide evenly into 12? Absolutely not. So rule 1 and 3 apply. They both tell us that this answer is simplified and we are finished. And it would be acceptable to leave that as our answer. All right, now let's say you're not the best at your division or you're knowing your factors. So you might be good at division, but you might not be best at finding your factors, those numbers that divide evenly into numbers. However, you're able to spot that 20 and 48 are even. You might not know they're divisible by 4, but you know you can divide by 2. Let's see what would happen if you did that. So let's say we have 48, and you're like, oh, they're both even. I know I can divide both of those by 2. So you do it. You get 20 divided by 2 is 10. 48 divided by 2 is 24. Well, and you want to know, is that my answer? Well, let's look at our rules. A fraction is simplified if the numerator and denominator have no common factors besides 1. So, do 10 and 24 have any common factors? Yes, they do. They're both even. We know 2 will go into both of those. So that means that this answer is not simplified. Just because you divided numerator and denominator by something doesn't mean that this is going to be your answer. So you just got to suck it up and keep on going. So you have to determine what will divide into both. Well, like we said, they're both even. You could divide by 2 again. 10 divided by 2 is 5. 24 divided by 2 is 12. We would say, do one of these rules apply? If it does, you're finished. Well, the first rule that says they can't have any common factors applies. 5 and 12 have no common factors besides 1. That means this is officially your answer and it's in simplest form. All right, let's apply this, or these rules, to one more example. 5 and 9/12. So, we want to know, is it simplified? Well, we know it's simplified if the numerator and denominator have no common factors besides 1. So, do 9 and 12 have any common factors? Absolutely. 3 goes into both. So, that means you have to divide by 3, or other numbers that you can find. 3 happens to be the largest number, so that's the one we actually want to use. So I'm going to make a note of that. 3 is the GCF, so that really should be the number you divide by. All right, on mixed numbers, be sure to keep your whole number. Do not change it. So 5 will stay a 5. All right, 9 divided by 3 is 3. 12 divided by 3 is 4. We want to know, is this simplified? Well, let's look at the primary first rule. A fraction is simplified if numerator and denominator have no common factors besides 1. Do 3 and 4 have any common factors besides 1? No, they don't. The factors of 3 are 1 and 3. Only 1 goes into 4, 3 does not. So that means this is simplified. Would any of these other rules apply? Let's see, a fraction is simplified when the denominator is prime. That's the nicest one. However, our denominator is not prime. So again, rule 2 is useless. It's like, why is it even there? All right, rule 3, let's see. A fraction is simplified when the numerator is prime, but won't divide into the denominator. Okay, is 3 prime? Yes. Will 3 divide evenly into 4? No. That means rule 3 applies, and that means you would be finished. So both rules 1 and 3 tell us that this answer is simplified. Now, what's an example that would apply for rule 2? Well, a fraction is simplified if the denominator is prime. So if I had a fraction like 4 over 7, 7 is prime. Because our denominator is prime, that means this is simplified, meaning this is a scenario where rule 2 tells us that this is in simplest form. Anytime that bottom number or denominator is prime, that means you're finished. All right, I hope this has helped with simplifying fractions and knowing if you can continue or not. If it hasn't, there's a lot of other information out there. I hope you find what you're looking for. You all have a great day.